Hello student, welcome back to another video. In the previous video, we have studied about the series combination of resistors. In this video, we are going to check the parallel combination of resistors. The link to the previous video will be attached in the description box. Do check it out. Let's get started with this video. So first, we will see the resistors in parallel. What do we understand by the resistors connected in parallel combination? As you can see here in this circuit diagram, you see this is R1, this is R2 till Rn. So n number of resistors are being connected here. Now the speciality of a parallel combination is that they will be connected end to end. As you can see here, the ends of each resistors are connected. Hence, the voltage across all the resistors will be the same. This is one of the very important point that we have to note in parallel combination. So all of the resistors will have the same voltage. However, they will definitely differ in the current. So if you are facing any difficulty in this kind of circuit diagram or any resistor is not working, then it is very easily replaced by any other resistor. Now, this is a very important advantage as compared to that of a series combination, because when we had a faultiness in the series combination, we have to replace the whole circuit. We have to stop it, we have to close the circuit, then we have to replace it. But here, this is very easy because we can replace one of the branch and we can substitute it with a proper resistor of the same value. Okay? So, similarly, when we studied the last video, we have derived the equivalent combination for a series combination. So here also we are going to find out the equivalent resistance for a parallel combination. Okay, so as we can see in this diagram, this is R1, R2, R3. These three resistors are being connected in parallel. This is a voltmeter which is connected in parallel. This is the battery, this is the key, this is the ammeter. And this is the current I which is flowing through it. Now let's understand the circuit very carefully. Now if you see here, the points in which the resistors are connected, okay, the voltage here, it's actually the same across all. So we can say that if I consider the voltage for R1 as V1, the voltage for R2 as V2, the voltage for R3 is V3, then V1 is equal to V2 is equal to V3 is equal to V. That is the same. However, when you see this current I, okay, now it is dividing. Can you see the branch structure here? So here, let me consider the current through this branch is I1. From here it is I2. From here it is I3. Right? Now they're again being merged and we are again getting back I. This is how the circuit is. Okay. So now from Ohm's law, what we are going to write? We know V is equal to IR. So we can write I is equal to V by R. Right? Now here the voltage is the same, but the current is different. So my total current I will be the combination for I1 plus I2 plus I3. Okay. Now, similarly, I can write for I1, considering this formula, that will be V by R1 because my V1 is obviously equal to V. Similarly, my I2 can be written as V by R2. Similarly, my I3 can be written as V by R3. Right? Now, let's substitute in this equation. Okay. So, what do we get? Now, I consider I as V by R, or more precisely Rp, because Rp is the equivalent resistance in parallel combination. So I'm giving the P thing, okay? Similarly, as we gave the series combination, we wrote Rs, okay? So this is given Rp. Now let's substitute all the values. So it is V by R1 plus V by R2 plus V by R3, okay? So now left hand side remain as it is. For the right hand side, I am taking V as common. So I'm getting 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so this VV is getting cancelled. So I will get 1 by Rp as 1 by R1 plus 1 by R2 plus 1 by R3. Now, did you notice something? In the last part, when we did the series combination, our RS was R1 plus R2 plus R3. So that time we discussed that the equivalent resistance for series combination is the addition of all the individual resistors. So obviously equivalent resistance will be greater than any one of the resistor, right? But what do we see here? We can see that this is basically reciprocal. Then it is getting added. So when it is reciprocated and added, the value will obviously be lesser. So another advantage of this kind of circuit is that if my resistance is less, right? So my current will be more. That is what we actually desire, right? If the resistor is resisting the current, then how do the current will flow, right? So this is another advantages of a parallel combination over a series one. Okay. Now another thing I want to talk about here is that if we consider n number of resistors, suppose I consider R1, R2, R3, all of them are equal to R, right? Let us consider that. So for n number of resistors, how can we modify this formula? Okay, so let us write 1 by Rp as, so now everything is same, right? So I will just replace it by 1 by R plus 1 by R plus 1 by R dot 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 till n, because there are n number of resistors, right? So now I can write one more step, 1 by Rp, I can write it as n by R, right? So I can write Rp as R by n. Again, please note that this formula is applicable when you take equal resistors. Okay? Then only this formula is applicable. Otherwise, we are going to use this formula. How many resistors are connected? You just have to use this formula. But if the resistors are equal, you have to use this formula. And this formula is important because in some of the numericals, you can directly apply this formula and you can find the answer. Okay? Please go through the derivation again because this is very important for your boards. Now, since we have already talked about series and parallel circuit, so we can make a basic comparison between the two, right? So let's see. For the voltage case, the voltage for series has been shared as we have seen in previous video. But the parallel voltage, all the voltage of all the components in the circuit will be the same. Similarly, the current for series resistor is the same for all the appliances. When we consider it for the parallel case, it is going to get divided, right? This is the formula that we have used. The total resistance for the series case is the sum of the individual resistance of the component as we can see here. So obviously it is more. But however, if you see for the parallel as we just discussed right now, it is the reciprocal of the total resistance. So it will always be less than one of the resistor. Okay, I hope you understood this topic. If you have any other doubt, please let me know in the comment box. Thank you for your attention. Let us see in the next video. Bye-bye. Take care.